Hey, how are you?
Wow, you're here.
Yeah. Good. Nah, y'all good. What you put on the mask?
Huh?
What you got on the mask? It's the first time I'm seeing that. Okay, I guess that works. But now,
There's so much.
don't be mad. Don't be mad. But that's not your desk.
This is it.
Don't you always like the other one?
Remember, should I give you my math test now? 'Cause
Whatever.
I had everything done, but you're gonna give
Hey.
it to me, right?
Hmm?
Okay.
I'm gonna verify it and then give it back. You got a tutor signature? You got okay.
Whatever I do for over,
Okay.
it was great.
Okay. All right.
With the full efficient and
Got you.
stuff in the back.
All right. Give me like a day.
So I didn't put this for you, I put this for me.
Got you. Give me like a day and I'll give it back.
No, no,
Gotcha. Yeah.
Yes, sir.
Mhm.
And I apologize, but can you even understand the corrections that I did?
I'll look it.
Sorry.
I'll look it over. No worries.
Yeah, I went to two tutoring sessions, one today in person
Yeah.
and Friday with Miss Mary, and she's the one I did the whole test with.
Keep the bond.
Yeah, she's awesome.
Yeah.
Like her.
I'll look it over and I'll give it back to you.
Okay, thank you.
I have someone else.
Oh, I got it. Hey, this.
Yeah, I got you. Probably. Is Sharon here? Sure, come here and see. Yeah.
Don't worry, Sharon, he's giving us the opportunity to take it to tutoring at a higher grade.
Psychology is hard, yo. I remember when I got my C in psychology. I was so happy. Yeah.
Get on my nervous.
Mhm. Does that mean you're not gonna be a psych nurse? The psych nurse? Yeah. Mhm. Okay, that's fair.
Right.
Mhm.
Challenging except that it's not sidewalk. It's just
But like psych nurse, like how can I say this now? It's a lot to study, but it's not so much like hands-on, Yeah. Hmm. But I mean, hey, if it's your passion, that's all that matters. That's all that matters. Yeah. Kids are fun.
I'm not working with adults, honey, and I'm going right back. Pediatrics, whatever.
I love kids. I could be so nice to kids because they don't know. I'm so.
I would need a whole psychologist on call.
That's what I'm saying, like,
Where's your comprehension?
children don't know better. But adults, we're supposed to know better. I'm not fucking.
You read about
Or
you read about the book you did on the translation of very.
oh yeah, the Miracle on 34th Street. Yeah. Mhm.
Crazy.
Like new newborn, like the umbilical cord was still attached, like new newborn. So you know what I think it was? I can't prove it though, but I think it was like a girl that was like really, really young. And like she might have like hid it from everybody kind of thing, and then it happened.
That's
Yeah.
if she want her mom.
But hear this though. Look where she left them. She could have like killed them. She could have threw them in the garbage. She left them in a crowded place that somebody would find them. So yeah, yeah. I think like it's messed up what she did, but you know,
But if they do, she's going to jail.
But you.
I know. Yeah.
And a lot of people might disagree with me and it's okay.
Oh, that's a serious crime.
It is. It is. They they probably didn't know. She probably hid it from them. You know. Yeah. Yeah. How you been?
Yeah, that's what I'm saying. Like,
It's so sad.
But what's something I was thinking though? Because I feel like she's young,
Yeah.
I feel like in schools they should teach you that like you could like what you could do in that situation, You know, because legally speaking, she could have went to a hospital, she could have went to a fire station, and then there would be no harm, no foul. You know, but right, but I think in the moment she didn't know about it. You know, yeah, mhm, yeah, yeah. And it was quick because the umbilical cord's still attached. Like that's quick. Yeah. Mhm.
You can't really blame her. She probably
Yeah.
didn't know.
But like I've heard far worse stories. Mhm. All right, so I didn't get to finish last time, so I want to start off with R, then we're gonna move on from there, right? So real quick, right? What does the correlation coefficient R tell us, right? The correlation coefficient R is a simple statistic from a data set of ordered pairs X and Y. It is a measurement indicating the strength of a linear relationship between X and Y. R is a unitless measurement ranging from -1 to 1, and R value close to 1 indicates that a positive linear relationship exists between X and Y. This means that as X increases, Y increases in a linear fashion, right? Keep in mind, like that sentence I just said, right? That's your interpretation of it, right? If it's a positive correlation, as X increases, Y increases, right? Like that, from left to right, same way we read a book. A value and excuse me, a R value close to -1 indicates that a negative linear relationship exists between X and Y. This means that as X is increasing, Y is decreasing, right? In linear fashion, right? Now, an R value close to 0 indicates that the relationship, if any, between X and Y is not linear. Okay?
Wait, oh,
Like when it's a whole bunch of dots all over the place and you can't tell if they're like increasing or decreasing, like that.
like a
Mhm. Yeah. That's the R value for 0, exactly. Mm-hmm. All right. Let's get into let's get into the warning labels now. All right. You know, just like with the drugs and all that, you have like the little warnings, right? This medicine can't be taken after midnight. Da, 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 right? Okay, so here we go. That's our warning label about correlation, right? So the correlation coefficient can be thought of as a measure of how well a linear model fits the data points on a scatter diagram. The closer R is the positive one or negative one, the better a line fits the data, right? Values of R close to 0 indicate a poor fit of any line, right? Usually, a scatter diagram does not contain all possible data points that could be gathered. Most scatter diagrams represent only a random sample of data pairs taken from a very large population of all possible pairs. Because R, whoops, just checking. Whew, just making sure it's recording, all right? All right. So because R is computed on the basis of a random sample of XY pairs, we expect that the values of R to vary from one sample to the next, much as the sample mean X bar varies from sample to sample. This brings up the question of significance of R, or put another way, what are the chances that our random sample of data pairs indicates a high correlation when in fact the population's X and Y values are not so strongly correlated? Right now, let's just say that the significance of R is a separate issue that will be treated in another section, right? Where we will test the population correlation coefficient rho, right? And that's the Greek letter rho. Okay. So basically what it's saying, right? Um, Remember when we're doing the mean, like with the average and stuff, we have like a population, but for whatever reason, it costs too much money, it's too big a population, whatever. We can't get the whole population to do the actual population parameter mean, right? Mu in particular, right? So we take samples and then we try to estimate like what the mean population could be, right, from a sample. The same thing is true for the correlation coefficient R, right? Sometimes there might be too much data in the pairs. It might be too expensive to get all of the data in the pairs. It might be impossible, et cetera, et cetera, et cetera, right? So we take a sample, and then from that sample, we're gonna measure, right, how correlated the two variables are, right? But it's a sample. Some samples might be more correlated than other samples, etc. Right? So that's what this warning label is trying to explain to you. So we good on correlation coefficient? I got you. So long story short, I can take a sample of paired data, random sample, right? Now that for whatever reason I can't get the whole population, so I'm trying to use that sample to find out how correlated the two variables are. You know, if it's a could be, yeah, yeah, but it's like for whatever reason I can't get the population, so different samples like respond differently. You know, like, so some samples might be more positively correlated than other samples. You know, some of them might not be correlated at all. You know, so just to let you know that even though we're doing this math or whatever, right, there's still a chance that what we have is not like a good representation of the population, so to speak. Right, 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 right. Yes, yes. All right. Hi.
This tutor, this is the second tutor, like,
Yeah.
I don't know what they be talking about.
For real?
And then I felt like he was getting at bad at me because I didn't know what he was saying. So I showed him the formula sheet and I asked him for each question, which formula on each sheet do I apply to solve the problem? He told me that the formulas that I'm looking for my question was not on that sheet. And he said, I don't know why he even gave this to you.
On both of them?
Yeah, for real. And then I'm like, because my biggest thing is solving the problems, the equations, I need to know which formula to apply.
Mm-hmm.
And every question that I did,
Yeah.
that we did together, I gave some formula sheet and I said, all right, which one of these formulas would I use for
Yeah.
a question like this? He looks at my formula sheet and he says, it's none of them. Yeah, so pretty much, so then I told him, I said, well, these are the sheets that he uses for the test. And this is all I had for me to actually remember how to do work. And he has to choose a calculator, but I don't know which is like each question I do, I'm doing every single formula on these sheets to figure out which formula I'm supposed to apply to solve the equation.
Okay.
So, yeah, I was only getting ready to cut that line up to be honest with you, but
Who was that?
What was that signatures on my test? Yeah.
I didn't say my very.
Yeah, because each question I told him, show me which one of you formulas.
Because I was just not conforming with you, and I got a.
They don't know that to do.
Yeah, pretty long.
So
It's
now
like,
it's
it's
a
Friday.
I'm gonna have a whole nother appointment tomorrow, with a whole nother, what two is gonna piss me off that? Mary wasn't no help either.
Mary?
Really?
You know what they actually was talking about?
She the best one. Yeah.
Like, I can't.
She the best one.
Charlie Franklin. Charlie Franklin.
He good too. He good too.
He's more slow, he's like more calm, and he helps you understand the.
I didn't really know how to use these stupid sheets, right? You just write text.
I got you. I got you.
Give us multiple choice, so it's not like I can sit there and say, all right, so I gotta go through each single formula on these stupid sheets to figure out answers to one stupid question.
But use it for the homework. Like, you know, when you go to the section for the homework, use it. Why?
More than my son helps me with most of this stuff, I'm not getting no helping this student
I got you. I got you.
in this college in general has been the worst experience of my life. And
No,
I can honestly say, being in this institution, I'm good. After this, I'm done. It's just a one and done for me. I'm good. I don't want to experience nothing like this ever again.
nah, you're gonna really love this when you leave. You're gonna see. Like BCC is really good. It's all good.
This man really pissed me off.
I got you. I got you.
So your feelings are so valid. I was saying, I heard him say it. Oh, yeah. He really said that there was nothing for us to use on the formula sheet. Actually,
It's all right.
it's not okay. This should be in the right.
I'll fix it. Don't worry. I got you. Alright. No,
No.
you over there to do your homework. That's it. Yeah, I know.
I
I know.
was very,
Mm-hmm. I know.
you are very little.
I got you. All right, so look, R is your sample correlation coefficient computed from a random sample of XY data pairs. Rho is your population correlation coefficient computed from all the population data pairs, X and Y, right? So let's continue. There is a less formal way to address the significance of R using a table of critical values or cutoff values based on the R distribution and the number of data pairs, right? The next problem at the end of the section discusses this method. The value of the sample correlation coefficient R and the strength of the linear relationship between the variables is computed based on the sample data. The situation may change for measurements larger than or smaller than the data values included in the sample. For instance, for infants, right, there may be a high positive correlation between the age of months and weights, right? However, that correlation might not apply when we extrapolate the results to people ages 20 to 30 years, right? So what they're saying is, right, as an infant gets older, their weight increases, right? But they're saying that if you were to extrapolate it to like if you were to like use it and make a prediction about an adult age 20 to 30, that doesn't necessarily happen, you know? Yeah. Right. Yeah.
And isn't R between 1 and 0?
-1 and
That's
one.
already-
Yeah.
So of course, the ages 20 to 30 wouldn't,
Yeah.
no, there would be no relation, it'd be 0.
It should be a complicated relationship, right? Because as adults, we have the ability to like go up and down in our weight, you
Yeah.
know? So yeah. All right. So the correlation coefficient is a mathematical tool for measuring the strength of a linear relationship between two variables. As such, it makes no implication about cause or effect. The fact that two variables tend to increase or decrease together does not mean that a change in one is causing a change in the other. A strong correlation between X and Y is sometimes due to other either known or unknown variables. Such variables are called lurking variables. All right. So correlation doesn't mean causation, right? So just because two things go together doesn't mean that it's because one is happening that the other is happening. Right?
So in regard- How does that apply to the line?
To a line.
Yeah.
So the line, because the line, yeah. So because the line is showing you a correlation, that doesn't mean that that's the reason why it's happening. Right. Yeah. So think about it like with the babies, for example, right? As the baby from birth gets older, their weight is increasing, right? So like that's a positive correlation, right? Now, you know that line goes on forever, right? So if I went from like let's say 0 to 9 months and then I just skipped all the way to like let's say age 20 to age 30, right? You would think just by looking from the infant, right, from 0 to like 9 months, that at the adult it should continue. The trend should continue.
Because I.
Right, right. So if it was causation, it would be true, right? But again, correlation doesn't imply causation, you know? Right. Yeah. Mhm. Yeah.
Sorry, being big.
No, you're fine. Yeah.
So you're saying correlation
Mhm.
is the relationship between two things, not the
Right.
cause and the effect
Right.
between two things.
Right.
All right.
Yeah.
That's it, you should have dumbed it down a little bit.
I got you.
The
Hmm.
opposite.
No, I think.
Not the opposite,
It's
it's
the
the relationship, but to a certain extent.
Hmm.
That's right, you got it
Yeah.
right on the nail, you got it, to a certain extent. But the math, I was the same way, I was gonna say.
I got you.
I'm still starting.
I wish I had someone I could tell you for more. Well, low hall, low hall on the fourth floor. Yeah.
Over there.
Yeah, it's free. Yeah, you just go every day. Yeah. Yeah. And they have snacks. That's right. All right. So in ordered pairs, X, Y, X is called the explanatory variable and Y is called the response variable, right? When R indicates a linear relationship between X and Y, changes in values of Y tend to respond to changes in value of X according to a linear model. A lurking variable is a variable that is neither an explanatory nor a response variable, yet a lurking variable may be responsible for changes in both the X and the Y. All right. So let's look at an example. Examples are fun.
One string.
These are like definitions, right?
Mm-hmm. Yeah.
You didn't put the vocabulary on rice base.
I didn't yet. I'm still working on that. I got you though.
That would help
Yeah.
a lot for us. Just want me to-
Nah, you're not gonna fail. Yeah.
Because I also pretty like.
I got you. I got you. So look,
I mean, if you give us the time, I don't mind writing it down either, but we don't be having time to write it down.
you don't have to take the time. Just watch the video and then do it then. You know?
Because I don't know right now, I gotta print stuff out and read it. I can't find videos.
Got you. I mean, you could.
I can't have nothing stuff.
I got you. I got you.
I mean.
I got you. No worries. No worries. All right, look, causation and lurking variables, right? Over a period of years, the population of a certain town increased. It was observed that during this period, the correlation between X, the number of people attending the church, and Y, the number of people in the city jail, was R is equal to 0.90, right? So, does going to church cause people to go to jail, right? Is there a lurking variable that might cause both variables X and Y to increase? Right? Right.
So what is this?
So what happened is they had data about people that go to church and they took data from people that are in jail, right? They did a linear correlation on it, right? And they found that there's a positive correlation. 0.90 is strong. So there's a strong positive correlation between people going to church and people going to jail. So as more people go to church, more people go to jail. Right? But the question is going to church mean that you're going to go to jail? Right? Well, let's see. So look, we hope church attendance does not cause people to go to jail. During this period, there was an increase in population. Therefore, it is not too surprising that both the number of people attending the church and the number of people in jail increase. The high correlation of X and Y is likely due to the lurking variable population increase. So because the town acquired more people went to jail and more people went to church at the same time. That's a lurking variable. Yeah. There's no, there is a correlation, but there's no causation. Right.
Relationship with the causation. There's no-
Right.
But people,
Mm.
it's just that the time.
Exactly. Exactly. So the population, that's the lurking variable.
So, Professor, this will be a positive, this will be a strong.
Positive correlation, right? Mhm.
Okay,
Yeah,
going this way.
right.
Talk about it. No. Hey, you gotta have some, serious.
Yeah, you got to. Right. All right, so the correlation between two variables consisting of averages is usually higher than the correlation between two variables corresponding to raw data. One reason is that the use of averages reduces the variation that exists between individual measurements, right? A high correlation based on two variables consisting of averages does not necessarily imply a high correlation between two variables consisting of individual measurements, all right? But you will see soon. All right. So that's it for R. Yippee. Let's talk about, let's see.
Everything we're hearing now.
Yeah.
Everything more of the first one,
No. I ain't got time for all that.
the same amount of questions,
No.
more.
Maybe less.
So
Yeah.
so
Mhm.
that, but difficult. Can we go through a homework question that most of us don't understand, please?
Absolutely.
So
Yeah.
Professor, the person I'm gonna see tomorrow is Tony Casper. So who is that?
The best person in the world. The best person in the world. With the what? No, no, it's a lady. Yeah. Yeah. With the I, not a Y. Yeah, yeah. Yo, she the best person in the world. OMG. Yeah. Y'all, oh, I told y'all. I got you, I got you. Yeah.
Professor took the whole class. To the librarian, they gave the whole class a calculator and they all had to give it back at the end of the semester.
That's true.
Yeah, she.
Yeah.
So you telling us about all this other stuff and you couldn't took
But I
it to
said-
the library?
But I said it to y'all day one.
Yeah, but the last time when they're not giving that right now.
Oh, that's good stuff.
They not?
They like, remember when I told you I took the
Yeah,
test and I
yeah,
bring it back, I wanted
yeah.
to, keep it, but they told me I cannot.
So
Yeah,
just
I'm
borrow
gonna
just
make
borrow it
you
every
pay for
time.
again. I'm gonna go.
Yeah, just borrow it every time. Yeah.
That'll cost me keep bringing it back. That's
Yeah,
why
she did say that.
Take out them because they able to keep it for the whole semester.
But I'm gonna go back.
I'll email the head librarian and I'll ask about that because I'm not sure. Yeah. But I'm okay with y'all just borrowing it for the test and then that's it. You know? Yeah.
It's like some kind of like.
Yeah. I got you. But wait, I'm about to start your favorite topic. All right?
Sad.
Money.
It involves that actually.
You could literally tell it after you.
You could. Now, but what was your favorite topic in Math 23?
Basic, and it's subtracted. It'd be easy.
Now, I know you could get it. It starts with a P. No. 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 Y'all got A's though for all these P words though. I didn't expect so many P words. Yeah. Not PEMDAS. No.
So it's not parentheses, it's not product, it's not. Why am I? Protein.
It's a second half of the class. I got y'all. Probability, yes. 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 No, that's her favorite topic. Yeah. So look. That's all it is. So what is probability? Yeah.
The probability,
What is that?
It's like saying, how many times did you get the number 4 when you plug in 1,000 numbers to this one equation?
Something like that.
hate those.
It's not that hard.
Yeah.
So it's not hard if it's on a multiple
Once you
choice test.
understand it, it's fine. Everything.
Professor, I think we deserve a multiple choice test. We've been so good, we've been trying.
Well, multiple choice is hard. Exactly. That's why. Honestly, if I could make your final, then I would give it to you, but I can't. Nah. Yeah. But don't worry, I always try to make that my test way harder than theirs, so don't worry. All right. No, for real, for real. Like I look for like the hardest question. I'm just like, yo.
Not pretty.
Uh,
Professor, if I'm everything
Yeah.
except my my feelings cost.
No, it's only a percentage of your grade. It's not your whole grade. You know? All right. So look, what is probability, right? We encounter statements given in terms of probability all the time. An excited sports announcer claims that Sheila has a 90% chance of breaking the world record in the upcoming 100-yard dash, right? Not Sheila. That's Shelly Ann Fraser Price. That's the name right there, right? Henry figures that if he guesses on a true and false test, right, question, the probability of getting it right is a half. That's true, right? The right to health lobby claims that the probability is 0.40 of getting an erroneous report from a medical laboratory at a low-cost health center. It is consequently lobbying for a federal agency to license and monitor all medical laboratories. So when we use probability in a statement, we're using a number between 0 and 1 to indicate the likelihood of an event, right? So probability is a numerical measurement between 0 and 1 that describes the likelihood that an event will occur. Probabilities closer to 1 indicate that the event is more likely to occur. Probabilities closer to 0 indicate that the event is less likely to occur. Easy, right? No, we're done with R. There's something else. Yeah. It is like that. Yeah. Eventually it gets tied together, but you learn about that in your next statistics class, not this one.
No, I said,
We got more nurse practitioner, remember? Yeah, I got you. I got you. So let's go through some vocabulary real quick. So this P open parentheses A close parentheses, right? This is read as P of A, right? Which denotes the probability of event A, right? If the probability of A is equal to 1, an event is certain to occur. If the probability of A is equal to 0, an event A is certain not to occur. Good, right? That's it.
So the one next to zero. It's gonna say.
So it's gonna be equal to either 1, 0, or something in between, right? But what I'm trying to say is the closer it is to 1, the more likely it will happen. Exactly. Exactly. It's likely to occur.
So 0.1.
Like 0 will never occur. Yeah,
It's not likely to occur, and 0.6 is likely to occur.
exactly. That's it. Yeah. Yeah. I feel like you took that from the homework.
Because it's so far from 1, where 0.6 is more than halfway to 1, so it is likely to occur.
I feel like you took that from the homework. Like that's legit a homework question. Like verbatim. Yeah.
Yeah, it's not.
I've been doing the other homework.
It's open. It's not open yet? Okay.
I've been doing the other homework, guys.
Everything is done.
Yeah. I thought it was open already. My fault. All right, I'll take a look at it then.
But I would like for you to go through homework 13 in class. That's the one I don't understand.
Take a look at that.
Yeah, 13 is hard.
13 questions.
Oh,
13.
thank you for the email. I fixed it. For you. Yeah. You could refresh it and then it'll work now. Yeah.
So is this on
Yeah.
the sheet?
Yes, in chapter 5, right? So it is important to know that probability statements mean and how to determine probabilities of events because probability is the language of inferential statistics, right? So, probability assignments. A probability assignment based on intuition incorporates past experience, judgment, or opinion to estimate the likelihood of an event. A probability assignment based on relative frequency uses the formula probability of event is equal to relative frequency, which is equal to F over N, right? F is the number of, let's say, successes or whatever that you're looking at, divided by the total number of everything, and is your sample size, right? Like the mode, it's like the mode divided by everything, right? The count of everything, right? So where F is the frequency of the event occurrence in a sample of n observations. 3, a probability assignment based on equally likely outcomes uses the formula probability of event is equal to the number of outcomes favorable to the event divided by the total number of outcomes. You could pretty much just remember this last one, number 3, and that'll get you through all the questions. You know?
Can you give me like an example?
Of course. Of course. What opens? Oh, it does? Oh, got you, got you, got you. You sure it's not for the next homework? No. This is the one before that. The 5.1. Yeah, that's this the easy stuff. Like, no, we gonna get there. We gonna get there though. We gonna get there. I got you. Got you. Right?
See, this one I wasn't doing the homework, I used the formula sheet. This is on the formula sheet. This is but the only thing on the formula sheet.
That's good. That's good. All right, probability assignment, right? So consider each of the following events and determine how the probability is assigned. So a sports announcer claims that Sheila has a 90% chance of breaking the world record in the 100-yard dash, right? Solution, it is likely that the sports announcer used intuition based on Sheila's past performance, right? So you know how people will like have a conversation and be like, yo, like there's an 80% chance this is gonna happen, but there's no data to back it up. They just talking. That's what that is, right? Intuition, you know? Like based on what it can be. It can be, right? But intuition is like it's malarkey, you know? Like there's no data to back it up, you know? Like you're basing it on like some past observations that you had in, you know, and you're just saying like, oh, I think this is the way it's gonna be, you know? Yeah. But let's look at another one though. A little bit different. All right. So in this one, right, Henry figures that if he guesses on a true false question, the probability of getting it right is 0.50, right? So in this case, there are two possible outcomes, right? Henry's answer is either correct or incorrect. Since Henry is guessing, we assume the outcomes are equally likely. So there are n equals 2 equally likely outcomes, and only one is correct. So by the formula, the probability of a correct answer is going to be equal to the number of favorable outcomes, which is 1, correct answer, over the total number of outcomes, which is 2. So 1 over 2 is equal to 0.5, right? 50-50, right? This is literally what 50-50 means, all right? And for this question, though, there's actual data to back it up, right? We know we have a question. The question has two answers. One of the answers is right and one is wrong. That's it, all right?
Can there be multiple?
There can be. We're gonna get to that. Yeah. Yeah. Most of our answers are gonna be like the multiple one, you know? Yeah.
On the same thing, right? Yeah.
We're just going through examples right now. So the right to health lobby claims that the probability of getting an erroneous medical laboratory report is 0.40 based on a random sample of 200 laboratory results, of which 80 were erroneous, right? So from Formula One, for relative frequency, that gives us the probability with sample size n equals 200 and the number of errors f is equal to 80. So the probability of an error is equal to the relative frequency, which is f divided by n, which is equal to 80 divided by 20, which is our 0.40.
So 100 is a number of
Right, all the medical lab reports. And
80%.
no, 80 is the number of wrong medical reports. Yeah. So you take the wrong divided by the total of everything. That's how you get the 0.40. Appreciate it. Thank you. Always, always, always. Even on your homework, just divide the two numbers and that's it.
It's actually kind of simple. It sounds complicated, but it's not that complicated.
I'm pretty sure the homework is complicated.
No, it's actually not.
Everything.
Yeah.
Let's see, they give you
It gives you more words, and that's why I like, well, more words.
More
different
words,
ways.
less numbers.
Right.
Actually, yeah.
Less words, less numbers.
Professor, and then that homework is also gonna be due when? You haven't told us.
Try and finish it by tomorrow.
No, I'm not doing that.
Yeah.
Are you crazy?
I want everything.
Go learn. I got you. I got you. All right, let's talk about expressing probability results. So the probability of an event A is a number between 0 and 1. There are several ways to write the numerical value of the probability of A as a reduced fraction in decimal form, rounding to 2 or 3 digits after the decimal is appropriate for most applications, as a percent, or as an unreduced fraction. This representation displays the number of distinct outcomes of the sample space in the denominator and the number of distinct outcomes favorable to event A in the numerator. My favorite, and what I encourage all of you guys to do, is D. Right? So, yeah. I'm not a fan of reducing fractions in statistics. I like big numbers, big fractions. I'm down for that. I don't even like decimals. Right. It's easy for you. Just write the answer. I don't even like decimals, to be honest with you. Right? Just give me fraction, big number divided by bigger number. That's it. You know? No mixed numbers. Little number divided by big number. Yeah. Remember, probability can only be between 0 and 1, right? So it can never be a mixed number because a mixed number is bigger than 1. Plus that. Yeah. Yeah. So it'll always be some kind of decimal. Hey, how you doing? Good, good. I miss you. It's been a while. How you been? Yeah. Oh yeah. Whenever you're ready. Yeah. Good, good. Which one? Okay. I'm sure that they're the same time next week kind of thing, you know?
Yes.
Appreciate it. So I'll look it over and I'll get back to you.
All right, I think.
Okay.
And the new one on the top.
Okay, you're good to go. Yeah, yeah. So we've seen ways to assign probabilities, right? Intuition, relative frequency, and when outcomes are equally likely a formula, right? Which do we use? Most of the time, it depends on the information that is at hand or that can be feasibly obtained. Our choice of methods also depends on the particular problem, right? So in a exercise, you will see 3 different situations and you will decide the best way to assign the probabilities. Remember, probabilities are numbers between 0 and 1. So don't assign probabilities outside of this range.
Yes.
It cannot be negative. It cannot be bigger than 1. Mhm.
This number is a decimal, but then this number has to be.
No, they're whole numbers. Whole number divided by whole number. Right. Yeah, but the top is smaller than the bottom. That's it. That works too. I just don't like decimals. Yeah. Yeah. Yeah.
They were 200. That's what you mean.
Yeah. Yeah.
Equal 0.4.
No, I don't care about 0.40. 80 over 200.
That's it.
Yeah, that's it. Yeah. Yeah. I don't even care about that. 80 over 200. That's it. Yeah. Yeah. All right, so look, the technique of using the relative frequency of an event as the probability of the event is a common way of assigning probabilities and will be used a great deal in later chapters. The underlying assumption we will make is that if events occurred if events occurred a certain percentage of times in the past, they will likely occur about the same percentage of times in the future. In fact, this assumption can be strengthened to a very general statement called the law of large numbers. All right? Law of large numbers, remember that.
It's, I don't like large numbers, so
Yep,
I think that's your law.
of course. All right. That's actually how you win in the casino, but that's another conversation for another day.
Oh, I
Okay.
Yeah.
Yeah. Huh? Yeah. I like craps. I like roulette. That's my journey. But 21, that's the rule. Yeah. See, when you know statistics, you don't have to gamble no more. Right?
Wait. To win?
Of course.
That's fucking smart.
Yeah, that was a good movie. If they catch on, that's right.
But I'm smart.
Right? Some of them are not. All right, law of large numbers. In the long run, as the sample size increases and increases, the relative frequencies of outcomes get closer and closer to the theoretical actual probability value. Right? Right? So yeah, basically this is like a reverse idea of what we were saying before about with the samples and stuff. So what I'm saying is like I take a sample and it has some sample mean, for example, right? And what I'm saying is if I keep increasing the size of that sample, eventually it's gonna become more accurate towards what the population mean is, you know? Right. So that's the law of large numbers. Yeah. It can be. It can be. What I'm saying, if we're talking about X's and Y's, right? I'm saying that I have this sample of X's and Y's, and they have some kind of correlation,
Exactly.
positive or negative, whatever, right? But that correlation may not represent what the population correlation is. Right. But what the law of large numbers is saying is that if I increase that sample, right, again and again and again and again, right, and eventually that bigger number is going to be a more accurate representation of the population.
This is what you said, that as more people attended church, more
Right.
people went to jail. There was no relationship, like there was no cause and effect. It's just that the population of the people were getting bigger, like more
Right.
people were moving there.
Right. Mm-hmm. Yep, that's it. All right, let's get this next one. Everybody said it was easy. See, I all better get 100 on the next test. Hmm? I'm taking off the hard question off of the next test, so y'all should be good. Something called normal distribution.
Normal distribution,
Yeah,
I already don't like it.
I got you. Normally, that's what people say. All right, so the law of large numbers is the reason businesses such as health insurances, automobile insurance, and gambling casinos can exist and make a profit. That's so true. No matter how we compute probabilities, it is useful to know what outcomes are possible in a given setting. For instance, if you're going to decide the probability that hardscrabble, will win the Kentucky Derby, you need to know which other horses will be running. To determine the possible outcomes for a given setting, we need to define a statistical experiment. All right. So let's talk about it. A statistical experiment or statistical observation can be thought of as any random activity that results in a definite outcome. An event is a collection of one or more outcomes of a statistical experiment or observation. A simple event is one particular outcome of a statistical experiment. The set of all simple events constitutes the sample space of an experiment. All right. Yeah, it is.
Basically.
But to tell you the truth, the real answer to your question comes in grad school. Because we're not really gonna design any experiments here. But we're gonna talk about what you do after you design the experiment. Yeah, the next statistics class is really cool. It's more hands-on, it's more major specific, you know? Right. Like how can I say this now? Like we're analyzing data in this class, right? But the data is about different kinds of stories, you know? But in your second class, it'll be about like health data. Yours will be like criminal data, you know, stuff like that. Like it'll just straight up, you know? But the techniques on how you analyze it are all the same. You know? All right. I got you. You say that now. Yeah.
Hot chocolate,
Mm-hmm.
but you know, I made it from
Yeah.
scratch.
Nice.
Like a
Wow.
specific recipe, so everything has to be measured.
Yeah.
The nutmeg that you scrape up,
Mm.
the cinnamon you scrape to the
That sound
chocolate,
official.
like
Really? Yeah.
I was doing the math in my head.
Yeah.
So this is that. Professor was talking about.
Yeah.
That's right now.
That's where I learned how to add fractions and stuff was from cooking. You know? Mhm. Well, it depends on your major. Yeah. But most people here is only two. Is this one, and then there's like a part two where you make the experiments and that's it. Not you. Nurse practitioner. Yeah. Yeah. Huh? No, no. Nurse practitioner, right? Yeah. 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 Bio doesn't have much math. Chemistry does. Yeah. Environmental? Not really. Yeah. And bio. Yeah. Yeah. Mhm. When do you what? Get in? No, you get in here now. Before you graduate. Yeah. Yeah. Yeah.
Accelerated program now?
Not really.
No.
But you're gonna graduate as an RN.
Yes, exactly.
Yeah. Yeah. So you should be going in like next semester or the semester after. Yeah. Yeah. Y'all be good. Y'all be good. Yeah. Should be good. Honestly, like don't say that. Cause you never know. Things be happening, you know. Things be happening. It's possible. You know, if you say you but look, say you graduate in December, you graduate January, and you graduate May, y'all all walk in the same time. You know? Yeah. 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 Now winter's popping. Winter's popping. Yeah. Yeah. I took sociology in the winter. Yeah, me too. Yeah. Yeah. But they have a whole lot of online classes now in the winter. That too, yeah. The whole English in the winter was all online. Yeah. I thought English was very hard. I mean, yeah. I barely speak good English now. You know, like, right? Oh, that's what when I was in Spanish class, that's what I used to speak also. Yeah, I got you. Mhm.
But so far, I already got most of the love signs like that. But it seems fun, like, it's amazing.
Nice.
Fun, yeah. Whoever did like chem bio, that was so,
You know,
I just don't sound angel.
you know what I recommend? Go to the tutoring labs, right? They have different tutoring labs for different different subjects. Go to the tutoring labs and ask the tutors who they think for what class. That'd be a good way to judge it. Yeah. No, the tutors. So for example, right? There's a bio tutoring lab in this building, right? You guys could go to them and ask them like who would you recommend I take for the class? And then yeah,
Like us doing.
yeah. The rate. Yeah. But the thing is that it's a mixed review, right? You can use statistics to like really talk about that, right? You have some people that they leave a review and it's really good. Like they'll tell you what to do in the class, how to get an A and all of that, right? That's what you need to read, right? Then you got other people that just like they don't say nothing. They're just like, I don't like the class. I don't like the teacher. Why? Like, you know? Yeah. Like for that person, you need to look at like the overall teacher's rating and then you can make a educated decision, you know? But to tell you the truth, you have to take it with a grain of salt because I've actually taken classes with professors that had bad rate my professor ratings and they were great for me, like the best teacher ever. Like, what are these students talking about? You know, kind of situation, you know? And vice versa, you know? Yeah, 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 yeah.
But you know, that's
Mhm.
to remember what you said.
Mhm.
I did review about my professor last semester.
Right. Yeah.
But. And I specifically was, I think he's a brilliant man, he's very good at what he does.
Yeah.
But in my review, I let it be known, like, if you're entry level, and you're new to this, he's not a person to vote. Because he's so used to like advanced. And I don't even understand why he's teaching at entry level class, so their brain is strong like that, his brain's too strong to teach a person like.
That's fair.
Put that in the
That's
review,
fair.
you know?
That's
People
fair.
would know. A
Yeah.
lot of people say about him, he do so well in his class. But the reality of it all is.
But they need to give explanations why.
Yeah.
You know, like were did you give it your all? Did you have outside things happening that prevented you from succeeding? Like little things like that, you know? Like what I wish people would write is the recipe on how to get an A with that person. And then when you go in, you could read what it takes to get an A, and then you could decide, you know what? I could do that. I think I could do this class. Or nah, this is like thank you for the information. Like you know, it'll work for some people, it's not gonna work for me. You know, like I'm gonna just go to the next one. That's the kind of reviews I wish that people would write all the time, you know? Like what does it take to get an A? You know? All right, let's look at this real quick. Using a sample space, right? Human eye color is controlled by a single pair of genes, one from the father and one from the mother. This is called genotype. Brown eye color, right? B is a dominant over blue eye color, let's just say L, whatever, right? Therefore, the genotype, capital BL, consists of one brown gene B and one blue gene L. The brown gene dominates. So a person with a capital BL genotype has brown eyes. If both parents has brown eyes, right, and have genotype um capital BL, whatever, right? What is the probability that their child will have blue eyes? And what is the probability that their child will have brown eyes? Mm-hmm. Mm-hmm.
Which parents need to play more strong.
Right. But that's like forcing it to happen though. So I'm saying just like randomly, like one night stand, what the baby gonna have? You know? Yeah. Okay. Mm,
Because like, you know what it is, you have more from your dad. Yeah, I know.
you remember like the Punnett Square? I don't know if y'all remember that from bio, right? So all right, let's say you got mom. Let me show you. Look, let's say you got mom, and let's say you got dad, right? Right. So what I'm trying to say now, I'm trying to think how to write this now. Hold on. So mom, right? They both got this BL kind of genotype, right? So the capital B was Brown, right? How you spell Brown? Brown,
Yeah.
right? And then the L was blue, right? BLU. So brown eyes, blue eyes, right? Trying to remember how to draw this now, right? So with the dad, he got the same thing too. He got brown eyes that runs in his family, and he got the blue eye gene that runs in his family too, right? So this is the Punnett square. I don't know if you guys remember this. Y'all ever seen this before?
Yeah.
Right? So here's what a baby could come out with, right? They could come out with brown and brown. This baby definitely got brown eyes, right? They could come out with brown and blue,
Wait,
right? Yeah.
it's a factor.
Mhm.
Grandparents, that's what it are.
That's what I was gonna say.
Right.
She beat me.
This is coming from the grandparents. Yeah.
Babies with green, blue, and highlight.
But what's the probability of that
The
happening?
low.
That's what we're talking about.
Yeah.
See, now you use intuition. Right? Yeah. Well, we're gonna see right now. I'm gonna show you. Mhm.
Like my mom, I looked like I was about,
For real?
yeah, I don't.
You sure you weren't?
Or my mom.
You sure you weren't?
No, I
I'm
just.
just joking with you. I'm just joking with you.
Safe mom.
So look.
Yeah, you get like she said. Yeah.
So let's look at this real quick, right? So brown and brown, that gives you this BB right here, right? That baby for sure got brown eyes, and when they have kids, they're gonna pass on brown eyes, right? Then you got this capital B, lowercase b right here. This baby got brown and got the gene for brown eyes and for blue eyes, but the brown is dominant. So the baby shows brown eyes, but the baby could have blue-eyed children.
Yeah.
You know? Yeah, yeah. And then right. And then this baby over here is the same thing, right? Brown is dominant. They definitely got brown eyes, but they could have blue-eyed children, right? And then this baby right here, this is the straight up blue-eye baby, right? Yeah.
Yeah, I'm like that, like that.
I know you got that gene.
But that.
Uh-huh. Yeah.
But my son doesn't, and then my brother ends up with, yeah, and then my brother's daughter doesn't have it. But his daughter don't, his daughter's daughter has it, so it's like, it skips a generation.
Yes, it does.
So it's like, what is the probability of his daughter's daughter developing asthma? Being, you know, bacteria, so like, other than.
So that's the next chapter. We're gonna get into that. That's the next chapter. But look, we got this chart right here to help us, right? But let's answer the question, right? Da, 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 da. What is the probability that a child has blue eyes? So tell me, so what is that? 2. So I want to know what's the probability of blue? How many of these squares have blue eyes?
3.
1.
Oh, wait. the
Right?
probability, I forgot.
Yeah.
Fox has pure blue.
Right.
Yeah,
Right.
yeah, yeah.
So it's one out of how many boxes? That's the chance of it happening. Right? So these parents have a 25% chance of having a child that has straight up blue eyes. Right. Right. You know? Yeah. You know? For example.
I buy the
She got good parents, that's what that is. You know?
Yeah.
Nah, when I first saw it, I thought they were contacts though.
No, you.
I ain't gonna front. Yeah. Mhm.
Contacts.
Yeah.
Some of them are contacts. Those are.
For-
I'm not pregnant.
I was gonna. Hmm? I'm sorry? On theory? The 30th? Probably not. Probably in November. We'll take next test. Yeah. I have like a lot more that I want to get through before we jump to the test. All right. All right, let me ask you a question. What's the probability of the baby having brown eyes?
No.
3 out of 4. Good.
3 out of 4, yeah.
Right?
Oh, cause it's going
Let's
to
see.
Yeah, you can see the capital and the dot, the capital represents the dominant brown, right?
How did what? So the brown eye is dominant, right? So you can either be a carrier of the blue, but brown is going to present itself, you know, or you be just straight up brown and you carry brown type of thing.
So
Mhm.
blue,
Right.
be dominant browns. That's why you put 1/4 for the blue.
Kind of.
One person. that
So
has
these
the
two,
blue feet.
these two right here, right? They carry the gene for blue eyes, but they you won't see blue eyes in them. You're gonna see brown because brown is dominant.
That's why you put a
Yeah.
blue feet.
Right. Yeah. Because that's coming from the dad up here. And this one's coming from the mom. Hmm. Fun stuff, right? Y'all should all take biology.
Forward to next semester, but I definitely have to like choose the right professors and the right classes.
Go to tutoring and ask the tutors.
Yeah.
Hmm.
But like Christopher Lee, I mean.
I've been on the BCC app and I've been asking students to voice their opinions. I have to, yeah. I've been on the BCC app, like what professors do you recommend and which ones do you not recommend?
Yeah, they got everything on that. I had to take it off my phone, but it's playing too much.
Yo, the gossip in there is next level. Like,
But I like how they give us textbooks though. There's a lot of people on there, they submit textbooks.
That's the.
tutors got the textbooks too.
I went off the guy today, I thought he had a textbook.
Right, what is it?
All right, so look, according to genetics theory, right? The 4 possible genotypes for a child are equally likely. Therefore, we can use a formula 2 to compute the probabilities. Blue eyes can occur only when this is the lowercase b genotype. So there's only one outcome favorable to blue eyes. By the formula, the probability of blue eyes is equal to the number of favorable outcomes, which is 1, over the total number of everything, which is 4, right? Brown eyes occurs with the 3 remaining genotypes, BB, the capital B with the lowercase b, and the lowercase b with a capital B, right? So by the formula, the probability of brown eyes is equal to the number of favorable outcomes, 3, over the total number of everything, which is 4, right? So there's another important point about probability assignments of simple events. The sum of the probabilities of all simple events in a sample space must equal 1, all right? That's really important. So the sum of all the probabilities must add up to 1. All right? And what happens when it doesn't? It's not a probability. But you'll see that in your homework. Don't worry.
And
Mhm.
you're applying today.
It's unlocked already. Yeah. You got time. You got time. Like realistically speaking, I'm not looking for another test until like November. So yeah.
Yeah, but you need to report that, because that's very petty. Yeah, you can report, that's petty, you can report that.
All right.
Like, you're not here to hate life and to hate school, and a teacher like that will make me hate my life and hate school.
I feel you. So we can use this fact to determine the probability that an event will not occur. For instance, if you think the probability of 0.65, excuse me, let me say it again. If you think the probability of 0.65 that you will win a tennis match, you assume the probability is 0.35 that the opponent will win. The complement of an event A is the event that A does not occur. We use the notation A complement to designate the complement of event A. So this next figure is going to show the event A and its complement, A complement. In the literature, the symbol A, I don't even know what that sign is, an A bar, A1, whatever, right? And A bar is also used to designate the complement of A. All right, I've seen these in other textbooks as well. Notice that the two distinct events, A and A complement, make up the entire sample space. Therefore, the sum of their probabilities is 1, right? So the complement of event A is the event that A does not occur. So A complement designates the complement of event A. Furthermore, the probability of A plus the probability of A complement is equal to 1. The probability that event A does not occur is equal to the probability of A complement, which is equal to 1 minus the probability of A. This is on your formula sheet, chapter 5. All right. So does this make sense to everybody?
Yeah, use what we did before.
Yeah. So like think of it like this. If I say that there's a 30% chance it's raining outside, what's the chances it's not raining? Yeah, that's what I'm talking about. This is it. Whatever you did in your head to do that math, that's what this is. Yes, always. Mhm. When you hear people like saying like, yo, I'm 1,000% not real. Mhm. Yeah, that's not real. Mhm. Yeah, go ahead. That's fine. Yeah. Just sign before you go. Okay. Got you. You good?
I'm rushing now.
All right, let's see you. So let's talk about the complement of an event. Oh yeah, office hours today. Y'all staying?
Yeah.
Awesome. All right. I gotta switch the location though. I'm going over to the lab right after this. So just come with me. All right. After class. You know on Tuesdays are office hours? Yeah. 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 I got you. I got you. Mhm. So complement of an event, right? The probability that a college student who has not received a flu shot will get the flu is 0.45. That's sad. What is the probability that a college student will not get the flu if the student has not had the flu shot? What's the answer?
Oh, just like 55.
0.55. That's the answer. How'd you get that? Good. So 1 minus 0.45. That's how.
So you always look
Let's see.
subtracted from 100, right?
Mhm.
So the one is basically the.
Yeah.
zero.
Mhm.
Oh.
Mhm.
Someone's time.
That's using the same formula that we just have right up here. That's the complement formula.
figuring it out. I'm waiting.
Do it in your head? Okay. That works. I got you. Hold on.
Alright.
Got you.
So Professor,
Mhm.
right with the tutor, I was showing him the formula, and so he said, this is the formula, but it's not telling you how you're supposed to use this.
Mhm.
So this is the formula, right, for how to use it. So A symbolizes the 0.45.
So A is whatever the story is telling you. And then, right. And then you just do 1 minus that, and then you get the answer to the question.
Okay. A is the 0.45
Mm-hmm. Yep.
plus B, the AC would be 100.
No. The one would be like the 100. You know?
Would be 100.
So basically what you're doing, the story is the probability of someone getting the flu. Right? That's A. Right? So what they're asking you is what's the probability of someone not getting the flu?
Basically, what's left over.
Yeah.
No, I get what you're
Yeah,
saying.
but she-
I'm trying to figure out how am I gonna use the formula. If you give me the test, right? And I
Mhm.
have the formula sheet, and you give me this problem. How am I gonna use this formula is what I'm trying to figure out. So the A in the parentheses it represents the 0.45.
Yeah.
And then, okay, so now you go
Hmm.
plus P and then the other A in the parentheses. What number is similar,
Use the second formula.
Can
The
we,
second formula gives you the answer.
can we not use that though? Like, will we get
So-
on, we don't use that at all? We just use.
If you could do it in your head, do it in your head. They did it in their head. They didn't even use a formula.
If we, like, she
Yeah, that's
said,
fine.
it'll be better.
Yeah, that's fine.
The way they did it,
Yeah.
okay? I'm just trying to figure out, when you give me this formula sheet to do the test. You don't give us multiple choice, that's it.
Mm-hmm.
So if I'm gonna use, if you give me an equation on these things, and you give me a formula sheet, and I
Mm-hmm.
look at the formula sheet and I wanna apply this formula to the problem, how is that gonna work? How do
So-
I know
so look,
which number
This is
represents A?
your formula right here, right? So the probability of A complement is equal to 1 minus the probability of A.
What is A?
What's
What is A, the number?
Well, what is A? Tell me. What's the story? What are they asking about? Getting the flu, right? So they want to know, right? What is the probability of not getting the flu?
You keep putting all these these letters, like, I just need to know,
Mhm.
what is this A symbolize? Is A a number?
A is this. A is them getting the flu. That's what A is. So it's 1 minus the probability of get the flu.
So we want minus.
Exactly.
Yeah.
Right? So this becomes 1 minus 0.45, which is equal to 0.55. And that's it. Easy, right? Well, this is how I always do it, right? Formula first, plug in the story, answer. That's it. Formula first, plug in a story, answer. Right? Nothing crazy. I don't know if you guys ever seen a Venn diagram before. Yeah.
Yeah.
So just to visually talk about what we just did, right? This is a Venn diagram to represent it, right? It's the same question that we just did, right? So the probability of A would be the inside of the circle. The probability of A complement is everything on the outside. And when you add the two of them together, it's equal to the whole space. Right? Yeah, so probability of A would be like the inside of the circle.
That'll be the 0.5.
So A.
That'd be the 0.45, right? And then the complement is everything that's not inside of the A, everything that's on the outside. Right. And when you add them together, you get 1. So that's the whole space, the whole square. Right? Sure. So this would be like the 0.45. And this would be like the 0.55.
Yeah.
Right? And if you do the probability of A plus the probability of A complement, right? We know that that equals 1. So that would be like what? 0.45 plus 0.55, which is equal to 1. And 1 equals 1. That's it. 100%. Right. That's it. So what you guys think? Easy, right?
Yeah.
Mhm.
I don't know if it is.
All right.
That's 100%. That one.
All right, let's do a quick summary real quick and then we can call it at that. All right. Just want to give you guys some important facts about probability. And then we'll pick it up tomorrow. So some important facts about probability. A statistical experiment or statistical observation is any random activity that results in a definite outcome. A simple event consists of one and only one outcome of the experiment. The sample space is the set of all simple events. And event A is any subset of the sample space. The probability of event A is denoted by P open parentheses, A close parentheses, right? The probability of an event is a number between 0 and 1. The closer to 1 the probability is, the more likely the event will occur. The closer to 0 the probability is, the less likely it will occur, right? The sum of the probabilities of all simple events in a sample space is 1, right? Probabilities can be assigned by using intuition, relative frequency, or the formula for equally likely outcomes. Additional ways to assign probabilities will be introduced in later chapters. The complement of an event A is denoted by A complement. So A complement is the event that A does not occur. And lastly, if you take the probability of A, you add it to its complement, it's going to always equal 1, right?
We add them
Yeah.
together.
You add them together. Yes,
That's
always.
acceptable.
Yes. That's another way to check it. All right, so that's it for today. All right. Have a good night to everybody on the recording. Thanks. Okay, no problem. I'll be